uniform circular motion. And this is just the intro. We'll go further in depth later this week. Okay, so what is uniform circular motion? Well, essentially, it's motion in a circular pattern at a constant speed. This means that the magnitude of the velocity never changes. It also means that that circle never changes radius either. So if, say, for example, in class, we spun a rubber stopper around, it would trace the same path over and over and over again at the same rate. This is a little trickier. What causes circular motion? Well, we discussed at the beginning of class that an object in circular motion has some sort of velocity tangent to the circle, and therefore, if for whatever reason the string, say, was cut, then the rubber stopper would continue along the line it was going at the moment it was released because of momentum and inertia. Well, that's all well and good, but what keeps it going in a circle then? And we discovered that we felt the string pulling outwards, which means the stopper was feeling a force inwards. So the key thing here is you need tangential velocity and an inward force. The most critical portion for it to be uniform circular motion is that these two velocity vectors, or the two vectors, velocity and force, need to be perpendicular to each other. All right? That means that just like when we did projectile motion, okay, where the horizontal component was never affected because the force was perpendicular to it, here the velocity never changes magnitude because the force is perpendicular to it, so all it can do is change the direction. All right, that inward pulling force is what we know as centripetal force, which means center seeking. It does not have to be an applied force. For example, gravity is the centripetal force for orbital motion. And there is no such thing as centrifugal force, okay? So I'm actually going to include a link after this to read about the forbidden F word. Okay, so let's think about this, what that looks like in a picture. So at any point, and this is a ball on a string, similar to what we did in class, the velocity is always tangential, and the force is always inwards towards the center. Okay, and you notice that for both of these situations, those are perpendicular. Okay, you can also picture it at another point along the path.